Okay, on this question, they're saying that the width of a proton is 1 times 10 to the minus 5 of the width of an atom. Wow, so it's a very small part of the width of an atom. Convert this number to decimal form. Okay, so it's 1 times 10 to the minus 5. That asterisk means times, right? Okay, so that's in scientific notation. How do we convert that to decimal form, meaning regular notation? Well, remember this minus 5, 10 to the minus 5, that tells the decimal to go back 5 places, right? Whenever you have times 10 to a power, that power talks to the decimal and tells the decimal, if it's negative, it says go back 5. If it's positive 5, it says go forward 5. Now the question is, where's the decimal, right? I don't see any decimal on the 1. There's no decimal there. Right. So where is it when they're not showing the decimal? It's really there. It's invisibly there. Where is it really? You know where it is? And if you're not sure, think about a price. What if I said, hey, the price on that piece of candy is $1. And where's the decimal? Well, you know that's the same as 1.00. The decimal's right there, isn't it? So if somebody doesn't put on the decimal with a price like $1, you know where it is. It's after the 1. Well, that's exactly where it is here. So you want to remember that. That's where it starts. And then it's going to move 5 back, right? So whenever they give you a number, if I say, oh, 27, there's no decimal point. Well, that's the same thing about prices as $27. The decimal is really right there, isn't it? So again, if they ever give you a number and they don't put a decimal anywhere, it's at the end. It's invisibly at the end, just like prices. Okay, so what? So, well, then this minus 5 tells this decimal, hey, decimal, you don't belong there. Go back 5 places. So 1, and it's to the edge, 2, 3, 4, 5. It brings in 4 zeros, doesn't it? So the answer becomes 0.4 zeros and a 1. That's the answer to the question. 4 zeros and a 1. Does that make sense? Because that minus 5 took that decimal, which was to the right of the 1, and said, go back 5 places, please, to where you really belong. 1 jump, it jumped over the 1, and then the other 4 jumps, it went beyond the edge, so it brought in zeros. Whenever they go beyond the edge, you bring in zeros. Now, sometimes students are confused. They go, well, Mr., should we put another 0 in the front? If you want to, it's optional. That 0 in the front is decoration. It basically does nothing. You can leave it on or take it off. Who cares? You think, well, why? The other zeros matter. Yeah, the other zeros matter because they determine how far over the 1 is. Does that make sense? If I only had 3 zeros instead of 4, that's a different number. Why? Because the 1 is in a different position now, right? He's in the 10th, 100th, thousands, 10,000 spot. And, anyway, it's a different position. So those zeros matter because they determine the position of the 1. But whether you have a 0 in the front or not doesn't matter at all. That doesn't determine anything. I just leave it off. And so there we go on that. So now let me do one more. This one will be a little bit easier. So on this one, we have 9.9 times, again, that asterisk says times, 10 to the 11th power. So again, what is that decimal? What is that power? Tell the decimal to do 11 to the right. That's a positive power now. So he's going to say, all right, decimal, you right here, you 9.9 decimal. You're going to go 11 spots, right? So 1, and it's to the edge. And then all the rest of the jumps are beyond the edge. So that's going to be 10 other jumps. 3, 4, 5, 6, 7, 8, 9, 10. It's got to be 10, and this is going to end up right there, isn't it? Because it does 1 jump and 10 jumps. That's 11 jumps to the right. Does that make sense? 1 jump to get over the 9, the second 9, and get to the edge, and then the other 10 jumps beyond the edge, bring in zeros. Whenever you jump beyond the edge, right or left, you bring in zeros. So it's going to have 10 zeros after it because it went 11 places to the right. First jump over the 9, and then the 10 jumps bring in zeros. So what is this number? 99 with 10 zeros. 1, 2, 3, 5, 6, 7, 8, 9, 10, whatever that number is, it's a giant number. It's the U.S. federal budget deficit. It's kind of sad. It's a huge, crazy deficit. Anyway, there it is. There's the number. And that's how we do scientific notation.